track session of the day. We will begin with Brian Granger presenting on why you should write buggy software with as few features as possible. Sounds very intriguing. He's from Cal Poly San Luis Obispo. And yeah, thank you very much.
Thanks. All right, so mic on, mic, okay. Hopefully I can convince you of my somewhat provocative title. And so a bit of background. In the summer of 2011, I actually skipped SciPy, locked myself in the basement of our home, and spent the summer developing the current incarnation of the IPython Notebook. If you're here this morning, you heard Fernando mention that this was actually our 6th attempt, and I think the number of lines of code that came from previous attempts was about a dozen. So it was mostly a new effort. And when we released this first version and started to show it to people, it was full of horrible, annoying bugs, and it lacked many really important features that we thought were absolutely necessary for this to be a viable piece of software. However, this was a deliberate choice on our part to leave many features out. And this came from our experience with the first failed 5 attempts, and almost without exception. I guess there was one exception of the 5th attempt that did not suffer this problem. We tried to over-design things, and the previous attempts basically were crushed under their own weight before they even got off the ground. In spite of the fact that there was all these bugs and many features lacking, the IPython Notebook became very popular very quickly, and it remains to this day a very productive piece of software. And this experience has really challenged our thinking about software development. And to this day, I should mention that the IPython Notebook still lacks most of these features and still has many of these bugs. So I want to start with a theory, in particular, a theory about software engineering. So here's one theory that we are tempted by, and that starts with features are good, then bugs are bad. Therefore, the ideal software will have lots of features and few bugs. The number of features and bugs is only limited by developer time, and you shouldn't release software until it has lots of features and few bugs. Based on this theory, you might think that this was crappy software. Twitter, compared to Facebook, has very few features, right? And yet all of us really like Twitter. And so there's some problems with this theory, and we can actually try to generalize this to another context to see how valid it is. So let's try to generalize it to food. So I like ice cream, so ice cream is good. Vegetables are bad, therefore the ideal diet will involve lots of ice cream and few vegetables. And the amount of ice cream involved is only limited by how much money you have, right? My 7-year-old likes this theory. So obviously there are some problems here, right? One, developer time is a finite resource. We don't actually have time to implement all the features that we'd like to implement, or even to fix all the bugs that get reported about our software. Here's some statistics that I looked up for some of the base projects in our community last night. And you can see that there's no lack of feature requests, there's no lack of bug reports, or even pull requests. The reality is that things are more complicated. Features have hidden costs. Bugs actually have hidden benefits. And in fact, we often love features, or love software that has fewer features, and Twitter is a fantastic example of that. So we need a rational process for deciding how to spend time as developers. Which new features do we add, which bugs do we fix, and how do we prioritize those things? And the thing that really got me thinking about this was actually the funding that we recently received from the Sloan Foundation for the development of IPython. And I think our initial response was, and some of the excitement in the community was along the lines of, wow, if IPython could do this many features with no funding, imagine how many features they'll give us with $1 million. And what we felt was that we really needed to remain very focused and not fall into this temptation to implement as many possible features as we could. And so that's sort of what prompted this talk. So I want to start out with the hidden costs of features. And I'm going to fly through this. There's a lot of them. So first, each new feature adds complexity to the code base. And that complexity makes the code base less hackable, maintainable, and extensible. And when you think about people wanting to attract people to a project, those attributes are really, really important. Each new feature increases the bug surface of the project. When a feature adds complexity, those bugs become harder to find and fix. Each new feature requires documentation to be written and maintained. You'll see that a lot of these hidden costs are related to the actual time it takes to implement features. Each new feature requires support over email, IRC, or HipChat. Endless feature expansion or feature creep requires developers to specialize. As your code base grows, eventually it's too big for a single person to keep track of and take in, and that requires them to focus on subsets. And that's already happened with IPython. IPython is now a pretty substantial bit of code, but it's also happened in some of the other projects in our community. I know it sure happened in SciPy. I have done a lot of work on SciPy, and yet I only touched the code in SciPy.physics.quantum. Each new feature has to be tested on a wide variety of platforms and environments. Each new feature adds complexity to the user experience. And this is a really important thing. I mean, there's the complexity that gets added from the developer's perspective in the code base, but it also, that complexity creeps out to the user. Sometimes it's the documentation or the API. Other times it's the UI or the configuration options. And this increases the cognitive load on your users. In general, this is a bad thing because most of the time, users are using your software because they want to get something done. And they want their mind to have space to think about that thing that they're trying to get done, not your software. So when you spend time on one feature, another feature or bug didn't get worked on. Again, developer time is a finite resource. So if you didn't prioritize things ahead of time, you just spent time on something less important to your users. I like to say that features multiply like bunnies, and the IPython Notebook has been the best example that I have ever seen of this. We put out the IPython Notebook, which is a new feature for IPython, and we have been absolutely flooded with new feature requests. Wow, that new feature Y is really cool. Could you make it do X as well? Features are really easy to add, very difficult to remove. I don't know if you've ever tried to remove a feature from software. Even if only one user in your thousands of users use that one feature, they are going to let you know and they are not going to be happy. So once you add a feature, you are stuck with the costs and the liabilities. You cannot easily get rid of them. So I'm not suggesting that features are bad, right? Features are the building blocks that make software makes us want to use software. I'm only claiming that they have costs that need to be carefully counted. So talk a little bit about features in the IPython Notebook. So there's a number of features, like I said, that we said no to initially. The multi-directory navigation. I hope that by now all of you are extremely annoyed by the fact that you have to start a separate IPython Notebook server for every directory you have notebooks in. This is a horrible situation. Multi-user capabilities, right? Right now the notebook is only aware of a single user. We have mentioned it before. There's no security model. It is an arbitrary code execution environment, and there's even subtle ways that you can leverage that. For example, you can write script tags in a markdown cell that causes a JavaScript bit of code to be downloaded, which calls into the IPython kernel and does rm-rf$home. And that code will all run when you simply open an IPython notebook. It does not require user action, right? This is a huge security problem. We completely ignored it. And it's still ignored to this day, by the way. So URLs, right now the URLs for notebooks have a UUID that's not particularly useful. it would be nice to have those be path-based and also have the name of the notebook. And then also auto-saving and checkpointing. I want to be clear. The day I sat down to start writing the notebook that summer, we had already thought of all these features. It wasn't that we later thought of them and, oh gosh, yeah, we forgot to add those features, we'll get around to it. We thought from the beginning, we absolutely need these features. And yet we made a deliberate choice to not implement them. And it made all the difference in the world in allowing us to develop the core experience that's become the productive part of the notebook. There's also some other features that we continue to say no to, that we don't have plans on adding. Extensible cell types, lots of cell and notebook metadata, or limiting the notebook's ability to execute arbitrary code for security reasons. Although I should say we are going to address some of the JavaScript vulnerabilities coming up. There's also some regrets we have, or lessons learned. There's a number of features that we said yes to initially, and then later backpedaled and said no, actually. One of those is an XML notebook format. Right now the notebook is JSON. 10 minutes, all right, thank you. And we developed the XML notebook format and realized this is absolutely a nightmare. It's horrible to maintain, and JSON just works. We also had Min actually spent most of an entire summer writing a SQL Alchemy-based database backend to store notebooks in. We basically threw that code away. We also built into the notebook format the ability for multiple worksheets for a single notebook. That is also going away. We also tried restructured text cells. And I can't emphasize, we spent literally months of time working on these features over 2 summers, and all that work has been thrown away. Some of these, for example, the multiple worksheets, are still in the notebooks that all of you are using. We're going to back that out eventually. And some of this, not all of it, could have been prevented had we been more disciplined about the following question. What's the simplest possible notebook we can implement that would be useful? Can we implement a notebook without an XML notebook format? Yes, absolutely. JSON works perfectly well. Can we implement a notebook without a database? Yes, believe it or not, there is no database involved in the IPython Notebook server. We're not storing any metadata, anything anywhere at this point. And we actually do not have plans, as far as I know, to add that. It's possible when we get into the multi-user stuff, we may have to add something like that, but we are trying to resist that as much as possible. Can we implement a notebook without worksheets? Yes, we've done it. It works great. Can we implement a notebook with a simpler markdown syntax? And the big difference there is that it's simple to render in the browser. Absolutely yes. So, a little bit more controversial, the hidden benefits of bugs. And I think this is one area where I've been really surprised. First of all, bugs are a sign that people are using your software. I don't know, I mean, I've got GitHub repos where I have software in, and no one ever reports bugs on them. And guess what? People aren't using it. And so it's a really useful metric, especially for open source projects that don't have any sort of formal way of tracking downloads. We have absolutely no idea how many people download or use IPython from all the various sources. And bugs are one way that we can gather data. 2, bugs tell you how people are using your software. And this is really useful. You can find out, well, what APIs are people spending time on? Bugs tell you which features are important, right? When there's missing features and there continues to be pain points for your users, the reporting of bugs about those features can tell you how you should be spending your time. That too is really valuable. One perfect example of that, and I guess I'm going to skip that example. Bugs are also opportunities to improve the testing of your software. I think adding tests to software is one way that you can mitigate some of the complexity that creeps in with features, but you can also use bugs to drive that testing process as well. Finally, Bug reporting and fixing can be a great starting point to attract new developers, right? You've got a user who reports a problem, you direct them to your GitHub issues page, they fill out the bug report, you start to talk with them on that, you point them to the code where that is, and they realize, oh, I can do that. And they end up submitting a pull request, and you've got the possibility of having a new developer. Again, I'm not suggesting that bugs are entirely good, only that they serve useful purpose in actively developed software, and that you can use bugs to extract useful information about your users and your software. So a few bugs that have taught us useful things in the IPython Notebook. One is that the IPython Notebook is broken on Internet Explorer previous to version 10. I'm not even sure how well it runs on 10. I know that 10 has the WebSocket support required, but we also use a flexible box model for the notebook, and I'm not sure how well that's implemented there. And we quickly learned that almost none of our users were affected. We didn't actually know this. Again, we don't have surveys of our users. I'm not sure. I don't think there's ever been a GitHub issue to make the IPython Notebook work on an Internet Explorer. Sorry, Wenming. We actually have a very good relationship with Microsoft, and they are fine with us running the notebook on Chrome when we're talking about how it integrates with Azure. And so it runs just fine. That's fantastic. This made a huge difference for us. So this allowed us to commit to using WebSockets very early on, before WebSockets were really in the mainstream browsers. This allowed us to write very simple, clean code in both the server and client, and to not have to mess with libraries like sock.js or socket.io that try to fall back to other solutions. There's also the jumping scroll bugs, and I know all of you who are using the IPython Notebook experience this all the time. So if you click on the output area of a large cell, it will jump up to the input area, and your output will scroll out of the way. The other one is that when you run a cell, we focus the following cell, and so the code that you wanted to see the result of can get scrolled out of view, and you're looking at the cell below it. So these bugs are annoying as hell. Users put up with it very graciously, even to this day, even in all the tutorials and the talks that are using the IPython Notebook. You see this all the time. It turns out that fixing these bugs in one way is really simple. We actually call focus in our code, and we can comment out those lines where we call focus. The problem is the rest of the user experience breaks completely. And this is really a problem. And it's taken us a long time of actually watching people and seeing how people use the notebook. What do people do when they run a cell? Do they want a new cell created below? Which cell should be focused? Do they want to be able to start typing immediately? Or do they want to be able to use the mouse to navigate between cells? All these questions have taken us a really long time to understand. We're just now starting to tackle this bug for real and trying to come to a solution that fixes these bugs while not breaking the rest of the user experience. And so this bug has actually been a really useful thing for us to have and gain that knowledge. So not all features should be implemented. So that's one point that I think I would like to make in this talk. But this is not a technical problem. It's actually a cultural problem, and it requires a cultural solution. So what do I mean by that? What this means is that you're going to have to say no to enthusiastic developers and users. We regularly have developers who introduce themselves to us by submitting a pull request. That's the first contact we have with them. And there's times where we have to say, no, I'm sorry. You've already spent a week of your time working on this feature. We're not implementing that feature in IPython. That is extremely hard emotionally and psychologically. And it makes it challenging to build a cohesive community where people like each other when you end up saying no like that. And so how do you do this without hurting people's feelings? How do you build this into your community and developer DNA? And I have about a minute, so I'm going to fly. So first of all, we have created a roadmap for our project that actually lists which features we're working on and which features we're not working on. We publicize this roadmap, discuss it with developers, the community, and make it an important part of the development process. This is really important. Define a finite scope or vision for the project, communicate that scope, and then implement features inside that scope. If there's features that arise outside that scope, just say no, they're outside the scope. You don't have to take it personally. Also, make features fight hard to be accepted and implemented. You don't have to accept a feature the first time it comes up. Wait till the whole community is crying out, we absolutely must have this. I'm going to skip that, skip that, skip that, skip that. So there's a lot more to be said about this. So in summary, decide on a finite scope for your project and communicate that to the community. And then implement a minimal set of features that cover that scope. Ship software with bugs and then use those bugs to extract useful information about your users and your developers. And to close, I want to give you some resources. The two books that have been really influential for me, one is The Lean Startup by Eric Ries, and the other is Getting Real by 37 Signals. You'll have to pay money for The Lean Startup, but Getting Real is a free PDF, and it is a quick read. Both of these are focused on commercial product development, but a lot of the ideas there apply equally well to open source. We have an IPython roadmap that you can Google for. And then I also have a couple of blog posts on my blog where I go into more detail about these ideas. And that is it. Thank you. We have time for questions?
Yeah, we have about 3 minutes for questions.
All right, Aaron.
Okay, so when you're talking about like the people knowing about specific parts of the project, like SciPy,
Yeah.
is that supposed to be a bad thing? Because like I didn't actually hear anything negative about that, and to me that seems like a positive thing. That means that the project itself is.
It's challenge for, yeah, so the question is it a bad thing when you have developers specializing and only knowing about certain parts of a project? One thing that I've seen in SciPy, for example, is that there's code that's replicated in various corners of SciPy. For example, the quantum stuff had a Kronecker delta function, and it was detached from and in duplicate of the delta function that was the other part of SciPy. And so it's things like that where you run into problems. But it's not always bad. Yes?
So I mean, a lot of this sounds like what little I know of agile development methodology, kind of very stress what you just talked about with that approach.
Can you repeat that? I wasn't.
So a lot of this sounds like an agile development methodology. So I mean, there are a lot of similar things.
Well, although you could use an agile approach and have way too many features. I think it's nice to have an agile approach. I guess I would much more describe this as customer-driven, customer-validated, where you really are focused on getting software out there quick, figuring out what your users need, and focusing on just those things, not sort of imagining what they might need and ignoring the reality of that. Yes, Gael.
Yeah, I'd like to pick up on the customer-driven and the fact that IPython never was reported as a bug.
Yes.
I think you've got a really biased sampling of your customer. Now, it's really a question of defining who you're talking to. But if you're going to go by get a bug, you're going to go by geeks.
No, absolutely. And yeah, I mean, I think the important point there is the customers for which we were developing the notebook are Chrome and Firefox users. Absolutely. But we did not know that beforehand. We knew that Chrome and Firefox were more used, but was Internet Explorer 0%, 30%? We didn't know.
Well, no, I guess my point is that they're users, but they're not going to submit a bug. They're just not going to. Well, they will potentially.
Okay. So they never even. Yeah, absolutely. So the comment there is that perhaps the people who use Internet Explorer found the bug and just left, never reported the bug report. Absolutely.
Okay, we're going to have to cut it off there.
All right.
So